We are going to finish up our unit on inequalities by graphing linear inequalities. It is a graph with a linear inequality, and we're going to find the set of points that represents all the possible solutions for that inequality. First thing we're going to do is look at some terminology here. This is the graph of y is greater than or equal to 2x plus 2. Here is the line for the equation, or the inequality. It's called the boundary. The boundary can be a dashed line or a solid line. We're going to find out in a moment what determines if it's dashed or solid. This is a half plane because this inequality will cut the coordinate plane in half. So this is a half plane and this is a half plane. And one of these half planes will be the points that represent all of the possible solutions. So let's look at the steps that will help us do this. Step 1, you're going to graph that boundary. You're going to use a solid line if it's less than, equal to, or greater than equal to. And you use the dashed line for less than or greater than. After you have graphed it on the coordinate plane, you're going to test a point to determine which half plane should be shaded. And then you're going to shade the half plane that contains the solution. You might want to go back and review the x and y intercept video or graph in the slope intercept form video. They will help you when it comes time to graph this boundary for the inequalities, because you're going to graph it in a very similar way. Look at an example. Y is less than x minus 1. So we know this is a dotted line because it's less than. We are going to graph the boundary. So negative 1, 0, we know the y-intercept is 0, negative 1. Count up 1 over 1, up 1 over 1, and then we now have our line of our inequality. It is a dotted line. Now we're going to test a point. You can select any point. Here I select 0, 0, plug in the x and the y values into our equation, and we see that this one is false. I can also pick, 2, negative 5. If I did that, this is the x and the y, and this one's true. So now I'm going to shade in the side that does not contain the point 0, 0, and does contain the point 2, negative 5, which is this side, and that's the side that would be shaded in. Another example, x plus 5y is less than and greater than 10. Do the x-intercept, which is 10, 0, y-intercept, which is 0, 2, and then make my line. This one is going to be a solid line because it's an equals to. Test the point, 0, 0. This is true, so now I have to shade the side that has that point, 0, 0 in it. Be careful with this problem. When you solve this out, you're going to end up with x is less than 3. And if you remember, when you get an x is like this, it is a vertical line. So we have a boundary that's a vertical line. You can test a point, 0, 0, and you end up with 5 is less than 14, which is true. So I will shade in the part that has that test point of 0, 0 in it. We are going to look at some of the test-taking strategies on the EOC where this is concerned. And until then, see you next time.